Hi, Alex. Hope that you're catching up on your rest and the craziness at home is calming down, and we all prayed for you and we'll continue doing that. So welcome to physics class today. We worked on vanilla. We're up to number 10. And then we started on the green sheet that looks like this that you have from the last time. So we're approaching number 8 where we need a new tiny-whiny concept to finish this green sheet, and here it is. What two things, class, come together to help define work? Force and distance. Force, parallel, and distance. If I go out and cut the grass in 5 hours and you go out and cut it in 3 hours, who's done the most work?
Yeah, it's equal.
It's equal, right. All right, because I did it in the same distance as you did with the same relative force, it doesn't matter. There's no time involved with work, only distance. And you cut the same grass that I did, you walked the same distance. So we have to come up with something to differentiate from me doing the job in 5 hours and you doing it in 2. So we came up with a new concept and we put time into it. It is power. Power equals work per time. And remember, work is force parallel times distance. Is that showing up okay, Aaron? Or should I switch colors?
That's good.
It's all right?
Yeah.
All right. So power is work divided by time, and that is what's going to get you through the problems on the rest of that green sheet. So let me give you one in your comp book so you can take it with you. Draw a rock. The rock is a 54 Newton rock. And it's going to be pushed 4.3 meters down the way. And it's going to take, that doesn't make sense. Work, I put an M, here's what I wrote. This is minutes. Now I know. It's going to take 2.1 minutes to push this rock 4.3 meters. That's some rock. So 4.3 meters isn't that long, and it's going to take us 2.1 minutes to push it using this force. So what was the power exerted? Find the power. So we come over here to our equation, and we do, it's work divided by time. So work is force parallel times x. So let's put in some numbers. So could you help me with that? Brendan, what is the force?
It's friction.
Oh, actually, I think I said the rock was 54 newtons. This is the push. That's the push.
That makes more sense.
Yeah, that makes more sense. So I'll answer that one myself. The force is 54. So Brendan, what do I put in for the distance?
4.3.
Right. And that's in meters, so we're good with that. Because if this is in newtons, we have to match. We have to match with meters. And time, does anyone remember what kind of time unit was hidden in the Newton?
Second.
Yeah, it was kilogram meters per second squared, so we can't use minutes. So what is, someone get me 2.1 times 60?
126.
126? Sounds right. And that's seconds. So make sure you work in appropriate unit. Tippy tap, someone give me the power.
3.44.
54 times 4.3 divided by 126. It should be smaller.
I got 1.8.
Should be smaller. That
Oh,
sounds.
I know what I did.
Okay.
Never mind.
1.8. What is the unit for power? Watt is the unit for power.
Watt.
Very good.
What?
That was bad.
Watt is the unit for power. So I think I only need to show you one to get you set to do the rest of the ones on that sheet. Our class is about over anyway, isn't it? When is it over? 10:15. Take this sheet home and finish it tonight. So if you haven't finished it, it is your assignment. So bring it back all done. How many do you have to do?
Trace.
Alex, I'll see you later. You can turn it off. Bye-bye.
All of this.